In this lesson, we'll be looking at the confidence interval for the difference in two proportions. So we had looked at in the last video that the standard error for our difference in two proportions is this. So we often don't know the proportion of our population. So what do? We substitute in our sample proportion for our best guess of our population proportion. Now, remember a confidence interval is your statistic, which in this case is the difference in our two proportions, plus or minus z star times our standard error. So the difference in our proportions plus z star, and then this whole square root thing again is your standard error, where we are using our p-hats for, which is our sample proportions instead of our population's proportions. And we can use this formula here, assuming that each one of these four items is greater than or equal to 10, because then it makes it essentially normal, and we can go ahead and do our confidence interval based off of that. So go ahead, read through the situation, and see if you can go ahead and construct your 90% confidence interval for the difference in proportions. And then play the video again, or start the video. So we need to make sure that we are meeting our conditions. So we got to take our sample size times our proportion has to be greater than or equal to 10, which it is. And then we look at the sample size of 167 times 1 minus that. Is that greater than or equal to 10? Yes, it is. So then we got to try the next one. Second sample size times the second proportion, see if that's greater than or equal to 10, which it is, and then second sample size times 1 minus the second proportion, and that's also greater than 10. So that's good. So we've met our conditions, so now we can go ahead and use our confidence interval formula for the difference in proportions. So we need to take our two proportions, which were 20% and 30%. We're going to subtract those two. Our z star, you would get that from going to StatKey and going ahead and doing the normal distribution and looking at what it is for 90% confidence. Then we got to take our first proportion times 1 minus that first proportion over the sample size. Second proportion times 1 minus the second proportion over the sample size of that one. So the 0.2 minus the 0.36 gives us the negative 0.16. Bring down our z star, plug this whole ugly looking root into our calculator, and we get this. So now we can go ahead and work that out. We can go negative 0.16 plus all this, and we get the negative 0.09. And then take our negative 1.6 minus all this, and we get the negative 2.37. So we would say we are 90% confident that the survival rate is between 0.09 and 0.23 lower than the metal tag penguins as opposed to the electronically tagged ones. We didn't include the negatives here because we essentially said that with the lower part. Now, this is what it would look like on StatKey.